All right, we're live and we're broadcasting and we're recording today. Let's wait 30 seconds more for the rest of the people to join and we will get started. Sounds good. Hello, folks. I'm excited to welcome everybody on our webinar dedicated to the topic of machine learning operations and reproducible machine learning with Kubeflow and Amazon SageMaker. This webinar is brought to you by Provectus and AWS team. A few comments before we begin. As we move through the content, you're very welcome to ask questions in the Go to Webinar Questions tab. We will address them during the Q&A session at the end of the webinar. We will share with you a recording with all the useful links shortly after the session. Today's objectives are the following. We would like you to learn how to build scalable and secure machine learning infrastructure on AWS and how Provectus can help you in that journey. We will discuss best practices of using AWS SageMaker and open source tools. We're going to marry two ecosystems of fully managed AWS tools and open source Kubernetes native projects for the better world and better life on our planet. Finally, we would like you to take something home after the webinar and offer a collaboration and one-on-one follow-up session, a deep dive into your machine learning infrastructure. So you will be able to elaborate on your pain points, ask questions, and receive recommendations for your use case from AWS and Provectus experts. We expect the audience to be familiar with AWS in general and with SageMaker in particular. It will be much easier for you to digest the following content if you are familiar with the machine learning lifecycle. We also expect you to have visited the home page of Kubeflow and you understand on a high level the value proposition of Kubeflow pipelines. We will start with the introductions, then we will quickly show you the happy end, a case study that demonstrates the real benefits of having machine learning platform, machine learning infrastructure thoughtfully designed and built on AWS. Then, once you understand the final goal, we will dive into implementation aspects and talk about AWS toolset, Provectus value add components for experimentation, machine learning operations, and feature store. And then finally, we'll learn details about fully funded machine learning infrastructure acceleration program by Provectus. Quick introduction. We have Stepan, Provectus CTO, who is speaking at this moment. The topic of this webinar basically describes my background in data, machine learning, DevOps, and cloud software architecture. I'm also very excited to co-present with Alex Chung, Senior Product Manager at AWS. Alex, please introduce yourself.
Hey everybody, my name is Alex Chung. I'm one of the product managers on the SageMaker Machine Learning platform here at AWS. And specifically, I lead many of our product integrations between SageMaker and the open source world. We're really happy to work with Stefan's team and Provectus again on doing another webinar.
Wonderful, thank you. We'll also have Q&A panelists, Rinat, Iskandar, and Ilnur, to answer your questions. Do not hesitate to ask questions in the Go to Webinar Questions tab as we move through the webinar content. So why am I talking about machine learning operations and infrastructure and claiming to know something? For those of you who have been in the industry for a while, it's not a new thing. AI companies were struggling with big data environments, analytical and machine learning pipelines for a while. I have posted this high-level article at KD Nuggets almost 4 years ago, which became surprisingly very popular. I was discussing all the challenges data engineers and data scientists are facing through working on their projects. Ironically, 4 years ago, I have summarized 3 major upcoming trends as tools evolution. We needed more tools to support machine learning lifecycle and to make the life of machine learning engineer easier. Education and cross skills. It was clear that data scientists had to acquire new skills like Docker, cloud, as well as basic software engineering practices. Process. At that time, I used term DevOps and its application for new type of workloads. So it's great about talking about it today. Even if we use new buzzwords, the main principles remain the same. Quick introduction about Provectus. So we are obsessed about extracting value from data through AI and deploying it to the real world. We ship end-to-end AI solutions for business, and we consult CTOs, CDOs, machine learning and data engineering teams how to build a foundational components like enterprise grade data platforms. Quick facts: we're headquartered in Palo Alto, have more than 400 employees worldwide, and we serve clients ranging from the cutting-edge startups to large Fortune 500 enterprises. And what makes us different, we're a APN Premier Consulting Partner, the highest tier for AWS partners, specialized in AI and ML. I believe there are only 6 companies in the world in our category. Some of our lovely clients listed here, we are comfortable working with big enterprises and driving multi-million transformational projects, as well as helping startups, partnering with them from the early stages through all the funding rounds and successful acquisitions or IPOs. So we have introduced ourselves. This is in poll time. Can you tell a bit about your company and basically answer the question, what is the level of machine learning adoption in your company? Yeah, let's spend 10 seconds, 15 seconds answering this question. So please let us know what's the maturity level of your company. If you're exploring, you're doing POCs, you're launching the full scale, you're scaling with the multiple use cases in parallel. Okay, collecting responses. So yeah, as I see many, like 1/3 of the attendees is exploring, 1/3 is building foundation, which is great, which is this webinar is focused on. Yeah, and another 1/3 is scaling. Let's finish the poll. All right. So those are the poll results. Let's continue with the presentation. So why machine learning infrastructure? All right, we would like to start by visualizing the final goal for you. The final benefits of having a machine learning infrastructure, and then work backwards discussing what's needed to achieve that goal. The best way to visualize the benefits of the solution is to look at the real world case study. GoCheck Kids is an amazing company that helps millions of kids to prevent vision impairment. The problem that we've been solving is a detection of an eye disease like strabismus or crescent based on images taken from iPhone application. We also had to reject images when child is not looking properly to the camera. Security and compliance is the first priority for these type of projects for obvious reasons. So machine learning problem was framed as an end-to-end image classification. So the problem may seem to be very simple, classifying cats and dogs. However, there is a huge difference in classifying cats for fun and deploying a real mission-critical solution to the real world on a real data sets. Let's look at the modeling hypothesis we have outlined during the research phase. We use different inputs, pre-processing, region cropping, and others. We use the different feature generation backbones from deep convolutional networks to the custom implementations. We use transfer learning from the synthetic data sets, and we tweak the objective functions to achieve the business KPIs. So, and obviously we experimented with different data splits. If you multiply all the variants, you will get more than 6,000 combinations to test and evaluate. And we always try to deliver a tangible result to the business within 4 to 8 weeks. So excluding exploratory data analysis, architecture, and infrastructure setup, we had only 3 real weeks for extensive machine learning modeling. And as a result, we have conducted more than 100 experiments on an entire dataset of 100,000 images. So each experiment usually have many trials and can take from 15 minutes to 6 hours on a single GPU. By experiment, we mean a tracked end-to-end experimentation on a cluster. We do not count development runs and the experimentation and notebook instances. While running one experiment, it was really important to move forward and configure a run experiment for the next hypothesis. Data preprocessing took about 5 hours, so we had to version output data sets and we used them in upstream pipelines. Security-wise, we had to minimize the access to the real data, even for machine learning engineers. Most of the full-scale experiments were run in a blind mode. When machine learning engineers works with metrics, reports, and logs without touching the actual images. That's quite important. This is the summary of the results and KPI. So we have improved the recall of the original rule-based algorithm by 3x. One of the greatest achievements is the fact that machine learning engineers were focused on modeling and experimentation rather than fighting with the infrastructure and data preparation. By the way, the final model in this case has been optimized for the iPhone application and deployed on the edge device. The main message here, this could not be possible without proper machine learning toolset on AWS. This is exactly why companies of all sizes need to invest into machine learning foundation in order to accelerate AI adoption. Quick poll time again. Let's keep it interactive. You saw some metrics from our case study, and the question here is, how quickly do you launch new machine learning projects in production? Obviously, projects are different. However, if you have some gut feeling and kind of high-level perception, well, how long does it take for your company, for your team to ship something to production? That's very valuable. Yeah, so I see 1/3 does not have any projects in production, so they don't have enough data points. 1/3 is of the audience has quickly ships machine learning projects to the production within 2 to 6 months, and another third is has 6 to 12 months of the release cycle for the machine learning projects. Very valuable. Thank you. Let's stop collecting this. Sounds good. Let's continue with the overview of machine learning AWS infrastructure for machine learning. Alex, please chime in. This is the floor is yours.
Awesome, thank you. I appreciate the introduction again and the case study that we saw here. So if we go into the first slide, AWS has the multiple investments and products around machine learning. And you can really think of this as 3 layers within the stack. At the very bottom of the slide, you can see that we have our framework. So we have support for TensorFlow, PyTorch, and MXNet on AWS. And also on top of that, we offer various tools called Deep Learning Omnis. These are prepackaged virtual machines with all the latest frameworks. We do a pretty large investment to make sure that they're up to date. We also have CPUs and GPUs. Currently, we have the NVIDIA Teslas. We'll be adding in the Amperes chips when they come out shortly. And then we also have tools like Elastic Inference, which allow you to do splitting of fractional instances of GPUs attached to your CPU-based instances. So you basically can get GPU acceleration while paying a price far closer to CPU instance types for inference. We also have Inferentia, which is the lowest cost of inferencing on the cloud, and it is a custom ASIC chip that we built. In the middle of the stack, you have the SageMaker platform. You have everything that I just discussed below, but it's packaged as a full end-to-end developer experience. So within the SageMaker Studio IDE, this is the first machine learning focused development console in the cloud, which is based off of Jupyter, but extended with many proprietary features. You can access various runtimes for library-specific environment. You can also integrate with our experimentation tools, our hyperparameter tuning, and then also doing things like autopilot and model monitoring, and also even things like debugger, which allow you to inspect the tensor as it is training and use that to do more sophisticated things like alarming or visualization of the model as it's training over time. All these different features are available also via open source native integrations, and we'll talk about that in a little bit. And then finally, at the top of the machine learning stack at AWS, you have what we call AI services, and these essentially abstract everything below that, ML services and frameworks, and it offers direct endpoints that you can leverage to do direct calls within your native applications. So it's really a one-stop shop versus the SageMaker platform is more hands-on. At the very bottom, it's essentially do-it-yourself DIY. So for the next slide, if you look at SageMaker, I already touched on some of the different components, but the lifecycle for machine learning starts with data collection and preparation. We have a tool called SageMaker Ground Truth, which allows you to do data labeling and annotations for amorphous, so tabular, computer vision, natural language processing data sets cost efficiently. Next, we have the SageMaker Studio platform, which encompasses Autopilot, which is our auto ML platform, model monitoring, which allows you to do a baselining of your training data and then comparing inference jobs against the baseline data when there are new inference jobs coming in. You have Notebooks, which is a different flavor of SageMaker Studio, which just offers a hosted notebook environment without any of the other bells and whistles. SageMaker Experiments, which allows you to essentially track and create model lineage of your job runs. You also have tools like Debugger, which I mentioned before, and then finally model tuning. We have several different algorithms packaged within our hyperparameter tuning solution, which allows you to find optimal hyperparameters for your model in a programmatic fashion without you having to manually start jobs yourself. And holistically, we built this platform off of customer feedback. And the customers that we have using SageMaker, next slide, are some of the companies that you're probably very familiar with. And just some of these names here, you can see there's Coinbase, there's Convoy, there's Tinder, there's many other well-known companies, and also Amazon itself uses SageMaker as part of its machine learning stack. So end to end, we really house some of the best tools that are used pervasively within the industry. And in terms of why customers use SageMaker, next slide. The reason ultimately comes back down to lower total cost of ownership. Total cost of ownership is the idea of the expenses that you pay for your infrastructure combined with your resources invested in terms of developer engineering time. And in study after study that we have, customers get up to 54% lower, at least 54% lower TCO, total cost of ownership, and the ability to leverage tools like managed spot training, so you can take advantage of low cost, high availability instances, and also having all of the security compliance handled for you ends up being a major value add for machine learning teams from startups, medium-sized enterprises, and even large Fortune 500s and Fortune 50s companies. And in terms of what we offer within the SageMaker ecosystem, we want to provide tools to the open source community as well, so that any developer that is coming in from a Kubernetes-based development shop can still access SageMaker. So we provide all of the best-in-class compute that's available in SageMaker and EC2, and we also add in EKS, which is our Kubernetes service, the managed control plane,
which allows you to run tools like Kubeflow really efficiently. And then we also have tools like ECR, which is a Amazon offered service for container repository management. And then finally, of course, you have SageMaker, which essentially integrates this entire ecosystem together. So in terms of the integrations that we created for SageMaker into the open source platforms, you have two flavors. First is Kubeflow, and specifically it's SageMaker components for Kubeflow pipelines. If you're familiar with Kubeflow, there's the idea of components which you can construct. And with Kubeflow pipeline components, you essentially can route portions of your pipeline to execute on SageMaker rather than running on your existing Kubernetes environment. And similarly, on Kubernetes, we offer more low-level integrations with the Kubernetes control plane to execute jobs directly on SageMaker as well. So if you have your own orchestration tool, your own built-in Kubeflow in your company, you can then leverage our Kubernetes operators, which then can execute jobs on SageMaker based on how your orchestration platform executes. And in terms of Kubeflow, really the interest that we've seen here at AWS centers around pipelines, and Kubeflow Pipeline is essentially an orchestration platform built on top of Argo. And this orchestration platform composes of a dashboard, a Python-based API, and then also a CLI, which allows you to make command line calls into Kubeflow, which then runs the jobs natively on Kubernetes. So Kubeflow pipelines offer this abstraction mechanism. And the reality is what we've seen, customers on AWS want to blend both SageMaker and Kubeflow. Next slide. Yep, there we go. Because it reduces the total amount of time to get from interest to run Kubeflow to running Kubeflow in production on AWS. It shortens that time dramatically when you leverage SageMaker as part of your pipeline composition. And the reality is SageMaker acts as your auto-scaling platform. You get perfect utilization and only build when you have jobs running. And also you get the latest updates and framework capabilities and also first-party algorithms that are included with SageMaker. And of course, you still get the portability, flexibility, and integration with existing CI/CD tools, and also the open source native composition of your stack through Kubeflow. So just to double click on how this works a little bit closer, Kubeflow pipelines is composed of steps, so nodes within your directed acyclic graph. And oftentimes, developers will package them within components. So what we offer in the middle section is a component that then runs on SageMaker. So you can have all your other components running on your Kubernetes cluster, and then you can have one component, particularly ones that are more intensive in compute, run on SageMaker, and you pull in the container from ECR. And essentially, this allows you to be consistent with the rest of your pipeline and also have your pipeline input-outputs natively integrate with Kubeflow metadata. And in terms of how this might look, you can also build entirely SageMaker-focused pipelines. So all of these steps within the pipeline here are running on SageMaker, and it composes of a processing job, a hyperparameter tuning job, a training job, and then finally a model deployment job. All of these are available within our SageMaker components, and also it gives you flexibility of options. You can bring your own container, which means you take any Docker container that you've built elsewhere, and then you slightly modify it so it can run on SageMaker. Or you can even do things like bring your own training script, which allows you to just upload code, and then SageMaker will then package the model for you and then execute that environment, saving you the hassle of managing a separate pipeline for building your containers. So if you think of the entire Kubeflow ecosystem, SageMaker essentially offers you a managed service version of everything so that you have the latest updates. You don't have to worry about backward compatibility, and you have all of the reliability of AWS while running your machine learning jobs. So just to summarize, we offer two different integrations with open source tools for SageMaker. Next slide. The first is via Kubeflow pipelines, where you can leverage our SageMaker components. This is a perfect tool if you're already using Kubeflow or interested in the Kubeflow experience for your development. And then we also offer the SageMaker operators for Kubernetes, which allow you to have lower level SageMaker job control within your Kubernetes control plane. And the difference between the two is that one is more advanced. The Kubernetes operators requires your team to have direct access into the control plane, or you have your own orchestration tool that manages the execution on Kubernetes. Or you can leverage our Kubeflow pipeline components, which allow you to compose pipelines in Python, which then run in Kubeflow pipelines, but execute on SageMaker. So I'm going to hand it back to the Provectus team, and I think they're going to dive more into how Provectus can complement your ML acceleration at your company.
Yeah, thank you so much, Alex. Really appreciate this. So we've learned Amazon SageMaker capabilities, and now let's see what Provectus brings to the table, what we offer on top of Amazon SageMaker to make it even more practical. So for those who has recently joined in this webinar, we're focusing on machine learning infrastructure and machine learning services. Together with AWS, we have prepared a special fully funded program to help you build machine learning infrastructure and accelerate AI adoption organization-wide. Stand by till the end to learn more about how to apply. Alex has already introduced core SageMaker services. This is an image taken from SageMaker homepage with all the main services we've just learned about. First of all, Provectus brings an expertise in SageMaker itself and also fills all the possible gaps and adds everything that is missing or could be improved in the original SageMaker offering. Machine learning workflow orchestrator, the core engine that sticks components of machine learning pipeline together. From the webinar title, you know we're going to dig into the Kubeflow today. Data sampling and versioning pipelines. The way you can switch from unbounded stream of production events to immutable, version, tracked, governed, and reusable datasets. A centralized feature store significantly accelerates model development and reduces overhead for feature engineering and feature serving. Advanced monitoring allows you to monitor data drift for text and computer vision-based models, as well as to detect not only statistical deviations in your production data, but also more complex anomalies. MLOps components for continuous integration and continuous training are also something that we're going to discuss today in more details. Let's jump right into the core concept of reproducible machine learning pipelines. So we have four inputs: the code of machine learning model, the code that describes machine learning pipeline steps, machine learning pipeline steps, and code that describes your infrastructure and dependencies. Obviously, any code is to be stored and versioned in Git. You also have a fixed, immutable, and version dataset as an input for your machine learning pipeline. A dataset is usually sampled from the centralized feature store. You can think about machine learning orchestrator as a meta compiler that takes all these four inputs and compiles it into the model. As any compiler, it outputs logs, metrics, and alerts, as well as tons of metadata to be stored and analyzed. That's it. Very simple. A beauty of this is the fact that it fits into a continuous delivery workflow as well as experimentation flow. You trigger the same pipeline manually to run experiment, and the very same pipeline is automatically triggered from GitHub and CI/CD tools for continuous integration and deployment. So this is the core, a backbone of your machine learning infrastructure and reproducible experimentation and machine learning operations. Everything else is, in our opinion, is secondary. Let's summarize characteristics of machine learning pipeline. It is a backbone of your experimentation flow. Machine learning pipeline is an integral part of your CI/CD flow. It's the main part of your continuous retraining workload, and this is a real production workload, unlike traditional CI/CD jobs. Machine learning engineers run pipelines many times a day and tests new hypotheses in debug models. And the pipeline execution should be idempotent. Same inputs should produce same outputs. It should not have any hidden state and side effects. There are four main components of machine learning pipeline. Pipeline DSL, Orchestrator, basically a DAG execution engine, and metadata tracker. The rest of the functionality is handled by integrations with debugger, hyperparameters tuners, TensorBoard, and other tools. There are quite a few options for implementation of the backbone of your machine learning pipeline. Let's take a look at what's available. Fully managed SageMaker service has a component called SageMaker Processing with its own DSL, and there is a SageMaker Experiments that Alex has talked about. There are question marks for SageMaker Processing since its functionality is pretty limited as of now in terms of processing of complex DAGs. User interface and integration with the rest of AWS ecosystem is also pretty limited. SageMaker Experiments could not be called outside of SageMaker. Although there are data science SDK and for step functions, and SDK to call SageMaker API. And integration between AWS tools and SageMaker is very limited as well. I believe AWS is working on this, and we will see new great things in upcoming releases. Well, obviously, reInvent is coming; is quite close. There are always pros and cons, and for each option. And in this webinar, we're not going to dive into side-by-side comparison. Please feel free to contact us after the webinar so we can look closer at your constraints and considerations. As of August 2020, in our opinion, Kubeflow is the most mature open source project that offers machine learning pipeline orchestration and metadata tracker, as well as out-of-the-box integrations with many other machine learning tools and services. It has amazing community, and AWS has recently started to contribute a lot of the integrations with the AWS native services. So you can offload complex tasks to Amazon EMR, SageMaker, and Athena. Let's take a look at the reference architecture of machine learning engineer-centric process with Kubeflow. ML engineer continues using well-familiar notebooks for exploratory data analysis. He or she runs data preparation pipelines to prepare a data set for his experiments. It is important that all of the data sets should be generated through the pipeline without manually executed queries. So it is tracked and versioned automatically. ML engineer updates the model code, tunes pipeline integration, and runs Kubeflow pipeline and observe metrics. The most crucial thing I would like to highlight here that it does not require extra skills from ML engineer and does not require additional overhead for hooking the code into Kubeflow pipeline steps. Here you can see how the pipeline runs are recorded in Kubeflow, so you can compare it side by side. You may notice here one of the cool out-of-the-box feature, ability to start a combined TensorBoard right from the Kubeflow UI. So Kubeflow is great, SageMaker is great. How can we benefit from having two awesome tools complement each other in a seamless fashion? As a reminder, Kubeflow owns an end-to-end pipeline, its execution and metadata tracking. You can have many purposely built Kubeflow pipelines for data preparation, model training, transfer learning, and others. SageMaker dramatically reduces TCO of managing infrastructure for complex training jobs, batch transform jobs, hyperparameter tuning, as well as offers many additional fully managed instrumentation tools. Using SageMaker components for Kubeflow, you can hook training and hyperparameters tuning steps from your pipeline to be offloaded into SageMaker. Model deployment Kubeflow pipeline can use SageMaker Neo and SageMaker Endpoints API to deploy the final prediction service at the edge or in the cloud. In this design, your Kubernetes and Kubeflow cluster becomes very tiny and lightweight and uses AWS managed services for heavy lifting. Let's review a reference implementation of MLOps, a buzzword that brought you here. We will be using Argo for CI/CD and Kubeflow for ML pipelines. As you may know, Argo is a Kubernetes native workflow engine. Argo CD is a continuous delivery engine built on top of Argo workflow, and it implements very advanced and very important approach called GitOps. As you may also know, Kubeflow pipelines are also built on top of Argo workflows. So it makes perfect sense to use Argo CD and Kubeflow pipelines together for end-to-end MLOps workflow on Kubernetes. In this diagram, experimentation cluster uses version datasets from DVC and executes an ML pipeline in Kubeflow, offloading training jobs to SageMaker. CI process executes the same ML pipeline that has been evaluated during experimentation runs, pushes all the artifacts into container registry, updates infrastructure state repository in Git, and then uses Argo CD to synchronize state in Git and actual state in the cloud. Well, this is cutting edge, guys. Are you still okay? Are you still following me? Since not many companies in the world have this type of setup. So this is how ML pipelines triggered from CI hooks recorded in Kubeflow may look like. Very brief screenshot here. Summary. Let's wrap up with Kubernetes topic. Here's a summary of best practices for you to take home. Invest into the library of reusable components. This is quite important. Use SageMaker components for Kubeflow, repeated many times, just a summary. Use EKS, obviously. Not in 2021, I believe nobody like just a few companies manage Kubernetes on their own. Now, use Argo or your favorite CI/CD tool to trigger Kubeflow jobs. So in our design, Argo is opinionated suggestion. However, you can use your favorite CI/CD tool. Benefits. You out of the box, you get metadata tracker and pipeline orchestrator, and with the minimal intervention into day-to-day machine learning routines for engineers. However, few challenges to be noticed here for the Kubeflow. It's still under a rapid development. So backward compatibility between different versions is painful. Moving your metadata from one version to another version is painful. So it's kind of quite, you will basically need a dedicated half-time or part-time or full-time DevOps engineer to take care of it. And just recently got attention from AWS, at least in public. So I believe we will see more and more contributions from AWS. So we've covered Kubeflow and SageMaker. I would like to briefly cover another very important topic, a feature store. I have 60 minutes webinar, and in this time frame, I can only give you a high-level, gentle introduction into a feature store. And we can have a deep dive into this topic during the workshop session that I'll talk about at the very end of this webinar. Let's have a third poll time. Obviously, the feature lake is a quite emerging topic, and we would not be surprised that not many of you are using this in production and kind of even thought about this. Let's touch some pain points that the feature store may address. Have you experienced any of the following challenges and issues? So please read it through. The question is not kind of trivial. It's important to understand the kind of the options here. Do you have the different machine learning models that you utilize the same features, share the same features between each other? Do you have issues that or challenges that the features are not reused? Basically, data scientists and machine learning engineers fork the raw data set every time and develop their own features, even if they are the same between models. Do you have an issue of kind of inconsistency, skewness of the training and serving modes of the machine learning models? Do you have the kind of the idea, the high-level vision of data scientists data scientists to have a more democratized access to the features and to the data they utilize for their machine learning models. And obviously, if it's not applicable, let us know. All right. Let me comment on the poll results. Yeah, not surprisingly, for almost half of the audience, it's not applicable, but I bet you will hear more and more in the industry, more and more from the startups, from cloud vendors, from AWS in the upcoming months and the year on this concept. So please follow me in this webinar. What is a feature store? Feature store is a data management layer for machine learning. You know, a machine learning model is trained on features, and features are being used in serving time. The main benefit of introducing an additional abstraction layer called feature store is to provide better return of investment from feature engineering. Imagine you have one data set and many different machine learning applications developed by many machine learning engineers. In this case, 90% of the features are to be reused between those applications. So we will need a way to collaborate and share on a feature level to avoid forking raw data set and accelerate development of new models. Features could be served in batch mode, in real time, in streaming, or sampled for training. All these patterns require different storage layers, and machine learning engineers will not always know the best way how to store and serve the features. So having it decoupled from ML pipeline will increase machine learning engineer productivity and system reliability in production. Consistency is one of the biggest problems in distributed system, and unified feature store aims to prevent training serving data skew by design. And feature store API is a good place to start tracking your data lineage and data versioning. So good news here, but that properly designed data lake covers probably 80% of system requirements for feature store. In a nutshell, it needs to have the way to ingest data. It should provide a data catalog. It should support API batch SQL access, and it should have consistent real-time index for online feature serving. The rest 20% is ML specific, API and metadata. The same analogy with Kubeflow. Why do we need yet another workflow engine? Because it is designed for a machine learning pipeline. Why do we need yet another data lake for features? Because it is designed for machine learning experience. Here we go. Let's see what makes feature store different from your S3 bucket with 135 different folders or from general purpose Redshift instance. First of all, it is API like get batch data with certain sampling strategy, random read, add or delete features. Second, metadata, lineage metadata, what models have been built from a particular feature. Data profiling metadata, mean, max, and other stats. Annotation metadata, agreements, judgments, etc. For supervised learning. And governance metadata, owner descriptions and versions, everything that enables discoverability and collaboration. Topics is pretty wild, and this topic is pretty wild, and there are just a few implementation options. FIST is an early stage project already included into Kubeflow toolkit and maintained project. Please follow links for GitHub issues here mentioned. AWS is adding a support for AWS native storage and other services. Definitely a good sign and good attention from AWS. Amundsen, another great open source project by Lyft. For AWS users, you can think about it as a very user-friendly data catalog that implements glue metadata, complements glue metadata with search and extensive metadata support. However, Amundsen it's not a store, it's just like a metadata layer, a data catalog layer. HubSworks, It's the most advanced project, in our opinion, with tons of functionality. It introduces many new abstractions and has the highest entry barrier for engineers. I use the term here by PhD for PhD, but just highlighting is quite the project is quite big. We were really surprised looking at that. It has much smaller community comparing to Feast and Amazon, and there is always sorry. And there's always an option to do it yourself. In Provectus, we've been building feature stores for a while in different capacity. There are always a lot of tweaks for different data types and workload patterns. Actual implementation might be different for tabular, image, or text data, for real-time and batch inferencing. There are many options for cold and hot and super hot storage, as well as integrations with the main data lake. So let's summarize what we've learned today. Machine learning infrastructure, modern machine learning infrastructure, accelerates time to value for machine learning initiatives and increases trust from the business. So it's not the black box anymore. It's something that is on a top priority workload for the whole organization. It eliminates handoff between data science and machine learning engineers. I have a strong opinion about that. There shouldn't be any handoff. The code that the data scientist starts writing, implementing the pipeline, should be automatically with a few tweaks deployed to production. If we have the right tools and the right frameworks, the right best practices implemented. This is a must-have requirement for organizations of all sizes, from the small machine learning shops to large organizations. And it also covers the straightforward machine learning use cases, as well as more complex, like recommendation engines and other pipelines. Must-have requirement for secure and compliant environments. You have to track everything. You have to build a white box, not a white box from these days. And obviously, as any code during even the first sprint, data scientists tend to generate a lot of code in Jupyter notebooks. So having the framework from that like ecosystem from the day one will help you to avoid the growing technical debt in machine learning projects. And so the last message, yeah, consider integration of AWS services with the open source projects for pipeline orchestration, experiments tracking, dataset versioning, and feature store. All right, hope you liked the content and the value proposition of having machine learning infrastructure on AWS. Let's see how you can get started. Provectus and AWS has jointly developed a machine learning infrastructure acceleration program. It is designed to help businesses build a robust machine learning infrastructure to accelerate AI adoption enterprise-wide. Basically, it is a one-day virtual discovery workshop with clear deliverables. We will help you to visualize a North Star, a machine learning platform on AWS that will serve the needs of your business in the long run. We offer the offering is available for a limited number of customers and is a fully funded engagement. Please dedicate your time, not money. Share with us your boldest goals. Big picture wise, workshop helps you to get started in just a few days. Deliverables include end-to-end solution architecture tailored for your use cases, adoption roadmap, and TCO calculator on AWS. Since the workshop is fully funded, we also expect a certain level of commitment and dedication from the customer's management and technical teams. After a workshop, we usually move to a very quick iteration, basically one sprint from start to finish, to get your machine learning pipeline deployed on a new ML infrastructure. Then we help you to scale and support ML infrastructure for other use cases in your enterprise. Please use the link in the GoToWebinar chat window to apply for a machine learning infrastructure acceleration program. It will also be sent you in a follow-up email with a webinar recording, so you will not miss it. We are recruiting only 10 customers to qualify for a fully funded engagement. All right, we're ready for Q&A. Hope you liked the content. Let's see. Okay, quite a few questions. Yeah, would we have access to slide deck and recording? Yeah, as I mentioned in the very beginning, we will send you a recording. We will send you all the useful links and the slides as well. Okay, same question from Daryl, and same question of Olatunda. Okay, one more question. Is there an issue with screen sharing? I think I'm sharing the screen. Okay, first technical question. How is Kubeflow different from Airflow? Good question. So this is kind of the intent of this webinar was not like to create a debate between Airflow and Kubeflow. The short answer is the following. So Airflow is the general purpose DAG executor for data pipelines. Kubeflow is the also DAG executor. First of all, it's Kubernetes native. It utilizes all the Kubernetes ecosystem operators, tasks, and control plane. Kubeflow is purposely built for machine learning workloads. It has out-of-the-box integrations with many with the machine learning toolkits that is crucial for machine learning pipelines.
I can take this question, expand. So specifically for things like Kubeflow, what Stepan alluded to, there's tools like experimentation management, there's hyperparameter tuning, there's the native TF job, PyTorch job, MXNet job operators that you can access that will automatically construct the containerized environments. All you need to do is pass in your code and then where the container resides for execution. A lot of these different steps are optimized for the ML experience. So if you're choosing a machine learning development platform for pipeline and MLOps, Kubeflow is many generations ahead of Airflow. Airflow has been, and the charter, at least so far, still remains focused on data engineering. So if you think about your ETL generation, and these aren't mutually exclusive tools. We oftentimes see customers using both.
Yeah, and if you see the components here, so there are three main components of the machine learning pipeline. It's a DSL, Orchestrator, metadata tracker, and UI and integrations. So Airflow basically is an orchestrator, and it has its own DSL. Kubeflow has metadata tracker and nice UI, purposely built for machine learning experience, and it has integrations with the machine learning ecosystem. All right. Oh, a few more questions. All right. Thank you for this introduction from Nick. Yeah, appreciate the feedback. Is Argo workflow open source or AWS supplied? Argo is the Kubernetes native workflow engine, so it has many sub components: Argo workflows, Argo CD, Argo CI is less kind of attended, but anyway, it is fully open source.
Argo is built by Intuit. They are the champions of the Argo open source. Kubeflow is open source, but they're a separate organization and charter group.
Yeah, that's correct. And obviously, kind of with EKS, you can use Argo workflows and Argo pipelines in a kind of less with less overhead than on vanilla Kubernetes setup. Good question from Jan. What is the benefit of using SageMaker MLOps in Kubeflow pipeline instead of using container op directly?
So the way to think about it is, if you are just getting started at your company with Kubeflow, by leveraging the SageMaker components, you don't have to do any of the lower level Kubernetes configuration of things like auto scaling, managed node groups, or the complexity at that level. By leveraging our components, the actual compute for SageMaker training is done in our managed compute environment. And what that means is all of that becomes executed for you using our preferred settings, or you can specify that as field parameters within your pipeline components. If you already have Kubeflow running in your environment, a reason why you might want to migrate is because we offer things like managed distributed training. So distributed training allows you to leverage multiple GPUs on a single instance, or you can leverage multiple instances and multiple GPUs. And you can stitch together some very complex accelerated training jobs. Also on top of that, we have advanced features in terms of inferencing and model hosting. So I talked about them earlier: model monitor, another one's multi-model endpoint, and those are just AWS specific features that we provide on SageMaker. And then finally, you have other tools like managed spot training. Spot instances are up to 90% cheaper than normal EC2 on demand. And what that means is, if you're always paying for GPUs on demand, that can rack up a very expensive bill. The cheapest, I believe, for the P3 instance types is $3 an hour. So with spot training, because you're using excess capacity of the high availability instance types, you basically can get that at a fraction of the cost, which makes training more models at a similar price to your current spend very, very attractive. And we offer a managed spot training service to handle the relaunching of the model artifact onto new instances whenever any of your spot instances go down.
Yeah, and I would like to add here that model training or hyperparameters tuning, model evaluation operations are much more complex than just running a container with a certain parameters. It's for instance like hyperparameters tuning. It's kind of quite heavy and quite science heavy. I would say it's much more complex than just running a container on Kubernetes. So we have an option. Either you would like to implement yourself or offload this into the SageMaker, and have another kind of point that Alex has mentioned. Yeah, managing and isolating GPU workloads on Kubernetes is a kind of will require pretty sophisticated and advanced ops knowledge of the Kubernetes. So by having the Kubernetes cluster tiny and responsible for this orchestration components and offloading the more complex workloads to fully managed service is, in our opinion, the best of two worlds.
Thanks, Stefan. The last point I'd make on this is, it comes back down to what differentiates your company or your product from others. Is it the fact that you can handle the machine learning models and create the best possible, highest recall, highest precision model possible? Or is it optimizing your low-level infrastructure on the compute side? I'd say most customers respond with the former, so creating the best model that solves the best business problem, and it's usually not focused on we have the best infrastructure optimized. You want to build things that focus on differentiating your core business against your competitors, and we can help you abstract away the afterthoughts.
Yeah, well, when on top of the hour, I appreciate that I think all the attendees are staying up to the very end of this webinar and presentation. Really appreciate it. And yeah, oh, there are a few more questions, quite a few questions. So after this webinar, we will be sending you a link to the Slack workspace, and we can continue chatting in this Slack workspace, and I will be answering those questions, some of the most interesting questions in the Slack workspace. So please continue collaborating, and we would be happy to elaborate on any use cases and questions you have. Yeah, that's yeah, Adi. Please join the Slack workspace. Happy to answer your questions there, Rajesh. So yeah, questions are coming and coming. So, but when on top of the hour, let's stop the recording and the broadcasting, and happy to follow up with all of you.
Thanks, everybody.
Thank you so much, Alex. Have a great and productive week.